Assalamu alaikum, dear students. How are you? So I hope Ramadan is going better for you guys. You are fasting well. Okay, so today we will start and try to learn how to multiply a polynomial by a monomial. So you already know what is a monomial and a polynomial. From my last video I explained what is the difference between monomial and polynomial. So let's say an expression such as a square plus b square. So here you can see there are two different algebraic terms. This is 1, this is 2. So I said in my previous class as well, if there is a plus in between two algebraic terms, these are known to be polynomial. A monomial is always, there will be no plus or minus. For example, x square y square, this is a monomial. Xy cube, this is also a monomial. Unless there is a plus and minus in between two algebraic terms, we need to understand that they are monomial. So this is completely one term, this is also completely one term, but since these two terms are separated by a plus sign or a minus sign, if you consider, then you can say that these are polynomial but these are monomial. Okay, so today we'll try to understand. Our first topic is to multiply polynomial by monomial. Okay, so we need to know how to multiply polynomial by monomial. I'll first show you a basic technique how to multiply, then we will use that method to solve different problems as well. For example, let's say the perimeter of a rectangle. If you have read it in class 5 as well, class 6 as well. So we know that perimeter of rectangle is what? 2 into L plus B. Well, L is length, B is what? Breadth. So 2 into L plus B means we multiply 2 by L first. We can write this in the same way, like 2 into L, then we put the plus sign, again we multiply the 2 with B. So this is actually what we call distributive property, where we are multiplying. If we put a bracket and if we put a number outside the bracket, we need to know that we will multiply this 2 with first L. First this 2 gets multiplied by L, then the plus sign comes, then again this 2 will get multiplied by B. So this is an example of distributive property, and while we will use this method to actually multiply polynomial by monomial. Okay, so let's now start with an example. So let's take an easy one first. Let's say I have an polynomial 5x square y plus 7xy square, and we need to multiply by 5x cube y cube. Okay, 5x square y plus 7x square y xy square, we need to multiply by 5x cube y cube. So we will just use this same technique. So we can write equals to 5x cube y cube. We first put the monomial, then put this whole polynomial in a bracket. 5x square y plus 7x y square. Now first we need to multiply this with this, then after putting plus we multiply this with this. Okay, this term with this term. First of all, this term gets multiplied with this term, then we will put a plus, then this term gets multiplied with this term. So if we multiply this term with this term, what do we get? 5 into 5 is 25. X cube into x square x5. Y cube into y to the power 4. Then we put the plus sign as it is. Next 5 into 7, 35. X cube into x to the power 4. Y cube into y square y to the power 5. So this is our answer. Got it? So this just the distributive method, how to multiply. Usually this is a polynomial, so I have multiplied a polynomial by a monomial. We just follow the same procedure as monomial by monomial, but just the difference is the plus sign. Okay, we need to put a plus sign in between the terms. Okay, let's give you another example. Let's say 2a cube, no, bigger one, minus 3x square z y cube plus 4z cube x y square minus 5 y4 x cube z square by minus 6x square y square z. Okay, so this is our problem. Minus 3x square z y cube plus 4z cube x y square minus 5y4 x cube z square. We need to multiply this with minus 6x square y square z. Okay, so the same method, first we write the monomial. So we can write equals to, first we write the monomial, minus 6x square y square z, and then we put the polynomial in bracket, minus 3x square z y cube plus 4z cube x y square minus 5y4 x cube z square. Okay, so this is my second line. So what do we need to do? We just need to multiply, same procedure as before. Is equals to, first this term with this term, then we need to multiply minus plus, what do we get? Then this whole term with this term, then this whole term with this term, we need to multiply. Okay, so how? Minus into minus is plus, so we don't write any sign over here. 6 into 3 is 18, x square x to the power 4, y square y cube y to the power 5, and z square. Again minus plus, minus into plus is minus 6 into 4, 24, x square into x cube y square into y square y to the power 4, z into z cube z to the power 4. Again minus into minus, minus into minus is what? Plus. This is 4. And 6 into 5 is 30. X square into x cube is x to the power 5. Y square into y to the power 4 is y to the power 6. Z into z square is z cube. That's it. So this is my answer. Okay, just follow the simple procedure that you need to multiply this with this, then this with this, then this with this. Okay, and we need to also check the signs as well. Minus plus, that's why I did not write anything over here. Minus into plus, minus into minus, plus. Okay, very simple. Okay, So from page 61, okay, I'll give you the task at the end. Next we will try and understand how to multiply a polynomial by a polynomial. So our next topic is polynomial by a polynomial. So let's say I have two expressions. Let's say 3x plus 2y. This is a polynomial and I want to multiply with another polynomial, that is x plus y. I'll show you two methods. You can use whichever you want. One is actually the checkerboard method, which is also in the book in page 61. Okay. Another is normal, which we used for polynomial by monomial, the same way. Okay. So in this case you can see there is a monomial, here is also a monomial. So what we can do is, first of all we consider this whole monomial. Okay. Then we multiply this with x. Again, next again we consider this whole monomial, then we multiply it with y. Okay. So let's say so 3x plus 2y, I've considered this whole monomial. Then we put what? We put x first. So with x I will multiply the whole monomial first, then we put the sign, that is plus, then y, then with y I multiply the whole monomial. Got it? So although these are two polynomials, but we can consider any one of the polynomials as a single monomial. Okay. First we multiply the whole monomial, polynomial with one of the terms of this polynomial, that is with x. Okay. Then we put plus y, and again we multiply the whole monomial. Okay. So what do we get? X into 3x, 3x square, plus x into 2y, 2xy, plus y into 3x, 3xy, plus y into 2y, 2y square. Okay, if you remember in class 6, the terms which have same variables, we need to add them up. Okay, here you can see xy, here also you can see xy. So we need to add these two terms up. Okay, so we can write equals to 3x square plus 3 is 5xy plus 2y square. So whenever you see two algebraic terms with the same variable, same type of variables, okay, here you can see xy, here also you can see xy, you need to add them up, or you need to subtract them as well if you have a minus sign. Okay, so this is your answer. Another method is checkerboard method. So what do we do in checkerboard is, we draw a square first. Okay, we need to know that, we need to understand how many terms there are. You see in this case there is 1 2 3 4, so 4 terms, right? So we will actually divide this into 4 boxes. Okay, next we put 3x, okay, 3x over here and 2y over here, x over here, y over here. Now what we can do, x into 3x is what? 3x square, x into 2y, 2xy, y into 3x, 3xy, y into 2y, 2y square. So if we add all the terms in the box, what do we get? 3x square plus 2xy plus 3xy plus 2y square. Next we add them up, equals to 3x square plus 5xy plus 2y square. Okay, so you can use either this method or this method, whichever you like. Okay, so this was an easy one. I will try and explain a difficult one with the minus sign as well, how to do with the ones with minus sign. Let's say a square minus 2ab plus b square, and we multiply by a minus b. So if we follow the normal method, we can write, first we write a, then the whole term, then minus b, the whole term. So a into a square minus 2ab plus b square, then minus b, again a square minus 2ab plus b square. And then we proceed further. A into a square is a cube, a into minus 2ab is minus 2a square b, a into b square, ab square, minus b into a square, minus a square b, minus b into minus 2ab, minus 2ab square, minus b into plus b square, minus b cube. So you need to always remember the sign, minus b into a square minus a square b, minus minus. Okay, you see minus minus is what? Plus. So I did not put plus over here, so it should be plus. Minus b into minus 2ab, minus minus plus, b into 2ab, 2ab square, minus b into plus b square is minus b cube. Finally, what do we get? You see here also a square b, here also a square b, so we need to compile them up, right? So you see minus 2a square b minus a square b, so we need to add them up, right? Before we know that from class 6 also we did minus 2 minus 1. If we have these two signs like minus 2 minus 1, what do we used to get? Minus 2 minus 1 is minus 3, right? We needed to compile them up, like minus, all the minus we add them up and then we put the minus sign. So over here as well, you see both have negative signs, minus minus. So this is 2a square b, this is 1a square b. So first of all we write a cube as it is, then minus 2a square b minus a square b, we can write minus 3a square b, because over here there are 2a square b and here there is 1a square b. So altogether there is what? 3a square b. Similarly, if you see here also ab square, here also ab square. So there is 1ab square, here is 2ab square. So 1ab square and 2ab square becomes 3ab square. So we can write 3ab square. And finally minus b cube. Got my point? So whenever you see a term, two terms with the same algebraic, means same variables, same sort of a square b over here as well, a square b over here as well, we need to add them up. If it's both minus sign, so we need to add them up and then put the minus sign. And again you can see plus ab square plus 2ab square. So ab square we put as it is. Here there is 1ab square, there is 2ab square, so 1 and 2, 3ab square, that's it, and the remaining stays as it is. Okay, and this you can also do with checkerboard as well, or you can follow the method done with example 9 on page 62. Okay, you can do either ways, but I think it's better to follow this method, because for the upcoming problems you need to be more swift. You cannot just break it down and do it. Okay, so this also can be done using checkerboard method. I'll just give an example. So you see over here there are three terms, right? 1, 2 and 3. So a square, so we need to make 3 columns for this. A square, then minus 2ab, then b square. And here there are two two terms, so here we write a and b. So this is how you need to draw the checkerboard. So a into a square a cube, a into minus 2ab minus 2a square b, a into b square ab square, b into a square b, b into minus 2ab minus 2ab square. Oh, this is actually minus b, forgot to write the minus, so this will become minus, this will become plus, and minus b into minus b into b square is minus b cube. So once we add all of them, a cube minus 2a square b plus a into, this is ab square actually, plus ab square, then plus a square, sorry, minus a square b plus 2ab square minus b cube. So we write just what is there in the columns, we just add them up. Okay, then again we need to follow the same procedure, a square b, a square b. So first we write a cube as it is, then minus 3a square b, then 2ab square, 2ab square, 3ab square, so plus 3ab square minus b cube. So you can either use checkerboard, but checkerboard, I think for the future problems you can't use checkerboard because it will take a lot of time. I think this method is the best to do because it will be more swift. Any sort of problem you can do it. Okay, but I'm just giving an example where I'm using checkerboard as well. Okay, so this is an example of where we can do polynomial by another polynomial. So let's now try and solve problems from exercise 4.1. So let's say I'm trying to solve example for exercise 4.1 number 24. So you can see there are three terms, here there are three terms. Okay, so what you need to do, with one you multiply the whole